Welcome to another episode and video on my walking robot Mirft2 based on the fischertechnik TXT controller running embedded Linux, programmed in Python using online mode, and as you can see equipped with two touch sensors on front, a camera for OpenCV and some rubber feet that are not completely functional yet. Also measuring the voltage to be sure the battery is not under its nominal voltage or doesn't get too low in voltage anyway, so the controller can't shut off, at least not in that way. Last time I changed the algorithm to separate red from blue and green in order to make sure that I know which colors I have to follow, and by separating the colors, well, during the separation of the colors I also found out that I had to change the setup of the camera, because it took one of these edges of the sensors with it, and if you want to see that color or this object or that color and object, you don't want to see this. So I had to modify the setup and frame to put the camera a little bit forward. Apart from that, I also found out that OpenCV channel separation, color separation actually is blue, green and red, and yes, that is the correct sequence. Normally you say RGB, red, green, blue. In OpenCV it is blue, green and red. And when I did some color separation, the red color disappeared totally. So instead of using red, I removed red. But let's see whatever happens with this walking. That's not what I want to hear. No. Why? Add the sound. Now, it took a picture ending on 52, so is that indeed? Oh, that is. In this algorithm it is not a moment, it is just a second. 52 seconds. So it made an image, but most likely it is not usable. And why it now starts rattling the gears, it's beyond me. Last time it didn't do that. But let's say that's the charm of surprise. Alright, let's do it again. But I have to first do something else, removing all images from last time, which I usually do prior to recording. But not this time, unfortunately. And now all evidence from last time is gone, and let's do it again. And let's see that all, well, that's the point. If you look right here, okay, something is amiss, and this has gone quite flexible. Well, it always was flexible, but and there is no space between the gears, so and yes, the flexibility is partly caused by the red gear. So if you keep in mind what earlier in this series I struggled with this red gear, and contrary to these axles, this is plastic, this is plastic, and this is plastic. Well, yeah, plastic, and plastic, so that is, and this one is extremely flexible. So in that perspective, it can be as flexible as this is. By the way, I do see some space in between the gears, although that should not be possible because I modified the frame that it can't relocate, that it can't shift away. Anyway, let's see how this goes on. Let's see some more color separation. So now, after this first run, some images already have been copied, and among which are two red channel images. So let's see what. No, using the wrong one. I need, of course, image magic. Oh, that's going wrong. I have another one which is 42 at then I have, right, this one was, I think, yeah, red image, and I still have to find out why TXT red is then 0. See, there's no red in here, while I would expect with a red separation, which I do right here. So blue channel, green channel, blue channel, green channel, red channel, that this would be red. Except that doesn't happen. You apparently take out red, as I found out last time already. So what can I do? I can, of course, do exactly the same for all the other ones. So, going here, and that is called red image. So then I would have to make this also the same. Right, then we say here green, what is the RB anyway? Red binary. If this is red binary, then this should be, say, no. Red, then this would be blue, and this would be blue. although this makes no sense because you're thresholding colors. Well, let's just see how this ends up. There's no problem in trying, and if it goes wrong, I know I have to try something else. It's as simple as that. So this will be then the blue image. And of course also a a green image. And then I'll have to do this as well. So I'll only do this for blue, and let's see whatever happens. What I will get to see here. And that will be especially nice since I don't have blue or green in the colors of those objects, because fischertechnik has no, I have to be careful here because new parts of fischertechnik do have the color green, but no blue. But the current colors are only black, yellow and red. So let's see how this ends up. 1, 2, 3, 4, 5, 6, 7 lines to copy. Here. It's not entirely correct, I think. Oh, that doesn't really matter. This one out. So this will be blue. And B image. No. Found in blue. F B. And then this will be, of course, blue. And here we say, of course, I am talking about not file name red, but red image. So this line will go, and this will be blue image. Am I doing correct? Not quite sure. I don't have a file name blue. Anyway, I'll notice soon enough. No. What am I doing? Okay. I'll notice soon enough if I screw up. So, let's see whatever happens. Okay, some rattling of, I hate that sound. Yeah, file name blue is not defined. That's what I thought. So this one going out, this one going out, and this one. Go. and I better put it in its trajectory, more or less. Connection reset by peer. I don't want that. Okay, it stops. But oh, now I notice why I did what I did wrong. I need an ampersand. Alright, so now does it have a blue image? No, it doesn't have a blue image. Blue image F. Blue image F is this. Ah, yeah, here, blue image. Why didn't it call blue image? Strange. There's nothing called blue image here. Oh, there is. Oh, good. Now I'm very curious what it shows. Okay, that's a difference. Quite a difference. But is it what I want to see? That's a very different point of view. Well, I have been doing some research and then it dawned on me that I was doing it the wrong way. If you look here, this is all black and white. Yeah, well, kind of logical, because you say here trace binary, and it may look different. Well, even a binary file has a gray, blue and a green channel, but that's not what I want. I want to see red, really see it. And some studying reminded me of an early project that I did with Bigfoot Classic, with OpenCV as well, and color recognition and color separation, and then I came back to HSV, UE, saturation and value. And in that color space, which is different from BGR, you can actually separate and define color ranges and then have a red image. So that is one thing. Now I need to make a lower red and upper red array to define the color range, and there is a little bit of a point, because what array should I choose? And of course the example I took it from is, by the way, just from OpenCV.org tutorial, but that leads of course to blue and not red as I want it, because blue is, as you can clearly see, not even present here. So how to figure out which values to take. That's a very good one. Next step. I could use these, for example. So if I just say 10, for example, 58 to 55, but that is then a lower range. But what is the upper range? I have no clue actually, because this is from example as well, and that is the point. What are the values? Well, U is saturation and value, and I know there is a very nice pie chart on HSV, so I think I'll get that and see whatever values I come up with. I think that is the best idea. Okay, so I found a nice map that tells me that red color is ranging from 0 to 10. Saturation and value are recommended to use this, but opinions vary on that. Anyway, let's save this and see what the result is when I get it. So, did I already save it? By now I did. Go, hopefully no errors. And I don't mind about walking, I mind about the picture. Ouch. Really? Now this is surprising. Very surprising. Oh wait, yeah, it's not so. Or is it? I think I need to insert this. I don't need this. Errors I could care less about. Alright. Now I need the result image. Okay, whatever. Ah, there's my result picture. It ends. And the result is TXT result. And there are two of them. Let me take 30. Okay, it does have red in it. And what about the other one? Okay, let's compare. It is this image. No doubt about it. And if I use this as an example, I do have red here, which is then clearly to see here. I do have red here, and this is reddish. But why is this not red? Why is this? So with this little experiment, I am quite clear that I can throw away everything that is not HSV. Well, not really, because like the very last one, let's say this one, is just the image that is a better way to compare. So the normal image I should take, and the rest can go. This one is better. Yes. Much clearer. So I should improve this part, and then the color is nice. I can also use, of course, yellow. Black is less logical because of this. This is blackish. So I should go for either red or yellow. And this is the way I should go also for the writing robot based on TXT controller Discovery, where I haven't even implemented color separation yet, but with this experiment I can quite simply put it in and then start using it with object tracking, and then saying which I can use here by the way too, because if the robot again starts to deviate from the course, from the trajectory, and red starts going here or starts going whatever way, I can stop one motor and go with the other to correct this course, and that's what this is about. So I think that's a very good way to go. And with this I have come at the end of the video. Let's also take a look at something that I've ignored for until now, is the battery voltage, which is 7.7 volts. So it has gone down, of course, but still working. Of course the front sensors haven't done anything, but the focus was entirely on OpenCV and resulted in a changing of the color space from ordinary BGR to UE, saturation and value. And that is the way to go for colors. Thank you for watching. If you like this video, please subscribe to my channel, give it a thumbs up, and leave a comment if you like. You can also follow me on Twitter. Then retweet please, and like and leave a comment, or follow me on Instagram. Like and leave a comment if you like. Please donate to keep videos coming to you, much appreciated. Also you can become a patron and have your name mentioned as a supporter. More information on my website, and this is of course going to be continued. and let's run it one more time. If it wants to or not. Okay. Yeah, never mind. I don't know why it rattles, but anyway, let's stop this. Thanks for watching, and bye bye.